Here's example 2 for the constant acceleration problems. So we have a ball rolling down a hill, has an initial speed of 2 meters per second, and accelerates at a uniform rate of 0.5 meters per second squared. After a time of 10 seconds, find A, the final speed of the ball, and B, the displacement over the 10-second interval. So let's write down our givens. We have a ball rolling down a hill. It has an initial speed of 2 meters per second. It accelerates at a uniform rate of 0.5 meters per second squared, and after a time of 10 seconds. Now for A, we want to find the final speed, and then for B, we want to find the displacement. So if I write those down, I know that my initial speed, or initial V, speed and velocity in this case are the same because we are just talking about an instantaneous velocity or speed, and it's just in one direction. So they are the same thing. So we get an initial velocity of 2 meters per second, and then it accelerates at a uniform rate of 0.5 meters per second squared. Now in this case, they're talking about it speeding up at a uniform rate of 0.5 meters per second squared. So since I have an initial positive velocity, my acceleration will also be positive. So that's a 0.5 meters per second squared. Because if we draw what's happening here, it's going down a hill, right? The velocity is down the hill and it's speeding up down the hill, which means that the acceleration is also pointed down the hill. Remember, those things are both vectors, which means they have a direction. After a time of 10 seconds, so t is equal to 10 seconds. For A, we want to find the final speed of the ball. So V final is equal to question mark. Now, if I scroll up to my equations, I know that I have initial velocity, I have acceleration, and I have time, and I want to find final velocity. So I can see that this first equation here, I have initial velocity, I have acceleration, I have time, and I want to find final velocity. So this is the equation that I'm going to be using here. So if I write that equation down first, we get V final is equal to V initial plus acceleration times time. So it's already solved for final velocity, which makes my life easy. So I get final velocity is equal to initial velocity, which in this case is 2 meters per second, plus acceleration, which is 0.5 meters per second squared, times time, which is 10 seconds. And then if we plug that into our calculator, I know 0.5 times 10 is just 5. And then adding that to 2, I get 7 meters per second. That will be our final velocity after 10 seconds. Now part B says we want the displacement over that 10-second interval. So displacement is delta x. So I have delta x equals question mark. And I now have final velocity as well. So I literally have every single other variable that I could use to solve for displacement. So we can just pick any equation that we want in order to solve for displacement. I'm going to pick the second one just because we haven't used that one yet, and it's already solved for displacement, which makes my life easy. So I get delta x is equal to the initial times time plus 1/2 acceleration times time squared. So our displacement will be equal to initial velocity, which was 2 meters per second, times time, which was 10 seconds, plus 1/2 times acceleration, 0.5 meters per second squared, times time, which was 10 seconds, squared. So plugging this into our calculator, we get for this first term 2 times 10, that is 20, plus this 10 squared is 100, because 10 times 10 is 100, times 1/2 is 50, and then times another 1/2 is 25. So our displacement here ends up being 20 plus 25, which is 45 meters for that displacement.